All right, section 3.4 brings us horizontal asymptotes using limits at infinity. So far we've talked about vertical asymptotes, which we get when we take limits as x approaches a number, not equals, but approaches a number, a. But now if we take a limit at infinity, what we get is we can get two possible horizontal asymptotes. One as x approaches infinity so that's what's happening on the right side of the graph as x gets really, really big. This is really, as we go to infinity on the x-axis, we're going to the far right side of the graph. And as we go to x and approaches negative infinity, that means we're going to the far left side of the graph. So what happens at those extreme sides, on the right side or the left side? We could have up to two different horizontal asymptotes if they're not the same, or we could have zero asymptotes, but we'll never have more than two. When we do have a horizontal asymptote, that means we have a horizontal line, and our graph is approaching that horizontal line. So a horizontal line is always expressed as y equal to some constant. So we have it, and the limit of our infinity limit will be called L. So notice on our limit, the number that's down here is an x value, and the limit or the function value is always a y value. So as we take the limit as x goes far right or far left, the line that we approach is a y value, and we express that horizontal asymptote as an equation of a line. So here's some examples of some limits. We say the limit of x approaches x, as x approaches infinity equals L. So the limit of f of x as x approaches infinity equals L. So you can see that our line in this example is approaching that pink line. That means it can cross it at some point in the middle of the graph, but as we go further and further right, it's approaching that pink line. That means as x is going to infinity, the function is approaching L. So we write that like this. And on this side also we have, as you go far right, the graph value approaches the pink line, or the L, the limit. This one too, you can see it passes over the horizontal line many times, but it gets closer and closer as it goes towards infinity in the right. Our left-hand limits are the same, except now we're going left. So it can cross over the horizontal asymptote at some point in the graph, but as we get further and further and further to the left, the blue line gets closer and closer to that limit of the pink line. So that means we have a limit at infinity, or a horizontal asymptote. So let's look at some examples. So on number 1, here's our picture, here's our graph equation. Looking at that picture, I can see as we go to the far right, remember this means when I go to positive infinity, that means when I go to the far right, what happens to my graph? My graph is approaching this dotted line, which appears to be at y equals 1. So its limit is 1. Same on the far left. Oops. Our graph is approaching that dotted line of y equals 1. So we have only one horizontal asymptote on this one, and that equation is y equals 1. Our next graph, we can see an example of one that has two horizontal asymptotes. The one on the far right approaches y equals 1. So far right, that means x goes to infinity, so that's 1. And on the left, it approaches negative 3. So as x goes to negative infinity, y approaches negative 3. So we have two horizontal asymptotes, and their equations are y equals 1 and y equals negative 3. In this graph, our horizontal asymptote is y equals 1. We also have a vertical asymptote at x equals -5. So our vertical asymptotes are always in the form x equals a constant. And our horizontal asymptotes are always in the form y equals a constant. So as x goes to the far right, we can see it approaches the y equals 1 line. So this value is 1. As x goes to the far left, or going to negative infinity, we can see it approaches that same horizontal asymptote, y equals 1. So these are our horizontal asymptotes. Now the ones below here are here and here. These are vertical asymptotes. Vertical asymptotes are the ones that have x go to a number. So we have a number. So our x line, our vertical line is x equals a number. And our function is approaching infinity as it gets closer and closer to that line on the left. So on the left, we put a positive infinity. But on the right, you can see this line is actually going down, so it's going to negative infinity. So the brief intro to limits, horizontal asymptotes.